Right, so this was from yesterday. This was from yesterday. What we started doing is we were looking at relationship between lengths and angles. So remember we started talking about if we've got things that are too tall to measure, okay, like this bridge, and we noticed that here is a right angle, just at a different perspective. We've got the cables that come from it. So we've assumed that we have perfect right angle triangles. And what I said to you, that back in the day, someone did some research and they noticed that there were relationships between the angle that you set and the sides of the triangle that are created. So I started by drawing this diagram. Imagine that that was the height of the pylon. This was the distance along the roadway, and these are the cables. Well, these cables would make the same angle, okay? So I then said, well, there is a relationship between certain sides, like the hypotenuse or the opposite or the adjacent. And so we looked at how to identify which side was which, because depending on which angle we look at, the adjacent and the opposite will be changed, all right? And I think we had some rules. Do you remember your rules? I asked you to write them down in your book. Okay. How can I identify the hypotenuse? Daniel?
The hypotenuse is always across from the right angle.
Yeah, that's good. Hypotenuse is always across from the right angle. So if I look at this diagram, here's the right angle, here's the hypotenuse across from it. Okay. Another way to remember it is the longest side. Okay. It has to be longer than the other two. Is it possible for the hypotenuse to be shorter than the other two? No, it's just not possible to happen. Not if it's a right angle triangle. Okay? Which makes us realise that this whole thing doesn't work at the moment if it's not a right angle triangle. Okay? What was our ways of remembering the opposite or the adjacent? Thomas?
With the opposite, it's always where the theta is like where that's pointing to.
Yeah, I remember that worked for you definitely, didn't it? Yeah. Yeah, so opposite is opposite. So the whole pointing thing, if that's the angle, these lines kind of go out in a direction and they go out to make the opposite. Okay? For me, adjacent means next to. The word adjacent means next to. So, you know, Owen is adjacent to Amelie at the moment. So, next to. So I think of adjacent being next to the angle. Right, it makes the angle with the hypotenuse. So the adjacent side is next to the angle with the hypotenuse, and the opposite is opposite the angle. And or if you want to remember it as the one that gets made or is pointed to. Or, so I ask you to write down in your book a way to remember those things. Okay. Now I want you to do that because the relationship between the two sides, right, was discovered, and the following relationships were found. Okay? So, the relationships are, someone noticed that if you take the opposite side, okay, the opposite side, and you divide it by the hypotenuse, you always get the same number. If you've got the same angle, if I do the opposite and the hypotenuse, I always get the same answer. In the same way, if I take my adjacent side and I divide it by the hypotenuse, I also get a different number, but it always ends up by the same number if it's always the adjacent. I'll explain a bit better in a minute. And then if I take the opposite side and if I divide it by the adjacent side, and I've left space for a reason, okay? Because I always get a certain value, okay? Depending on what triangle I'm using. So what I mean by this is, Have you written those down, by the way? Left yourself a bit of space, and I'll come back to it. So just to go back to the bridge, okay? So the picture of the bridge that I was talking about. Right? So the important thing is here, look, we said, here's the height, here's the roadway, and I've got all these cables. And I said here, look, the cables are all strung so that you'll notice they don't all go to the same point either, and they're all lined up so that the angle, either at the bottom or at the top, is exactly the same. So all these cables are parallel. We did say there was a bit of a kind of change, which is what's not quite so realistic about that, did we say? Do you remember? Yeah, the wires sag a bit. They're not perfectly straight. But this is the situation. So these ratios are such that if I take my cable and I string it up like that, we get an angle, right? Now, I'm not changing the other things, but if I take the opposite in the hypotenuse, that would be this side, yeah? And the hypotenuse would be that, yeah? Right. So if I took that ratio, opposite divided by hypotenuse, it would just be a number, right? Whatever it was, yeah? So let's say the opposite side was 8 and the hypotenuse was 16. What would opposite over hypotenuse be? Not 2. Not negative 2. 0.5. A half, yeah? 8 divided by 16 is a half. All right? So what they noticed was, if you take the same triangle, okay, but I take a different cable and I measure, and I make sure that that angle is exactly the same. Okay, so that's still the same angle as over there. So these are parallel. All right? What they noticed was, if you now take that shorter, it's now a shorter opposite, isn't it? But the hypotenuse is also shorter. They noticed it was the same ratio. So for instance, if this was 5, this would be 10, exactly. 5 and 10. Make sense? And if I take another one, so let's say another cable like that, and let's say that is 3, what would this be? 6. And that's set by that angle. Yes? Yeah, so I've given you a nice situation, all right? I've given you a very nice situation. But what I'm saying is that ratio always stays the same. Now, it's not always a nice ratio, okay? Can you see how the ratio depends on the angle? So, for instance, I think we talked about if I took a different bridge, let's say I took a different bridge where it's a bit higher and a bit shorter, okay? This time, what can we say about the angle? Oh, stop. It's a bigger angle, okay? That angle is much bigger than that angle. But if I did the same thing, if I laid another cable, that angle is going to be the same. But this opposite side and the hypotenuse, the ratio would still be the same for that triangle. Not the same as the other triangle because the angle's changed. Does that make sense? So we are just looking at a number. Now what is that number? Okay. Now, you've got your calculators. Now we've got our calculators. Let's just say I've got this bridge and I know that this height of the tower up to this point, let's say it's 73 metres. All right? And then let's do this length along the roadway is 31 metres. All right? what is the relationship between the so what two sides have I given you now? So the opposite and the adjacent. And if someone looked at that one, okay, so the opposite over the adjacent is 73 divided by 31. And what do I get? 2 point. Is that it? Exactly.
5483871.
Okay, so we get quite a long decimal. So it's not a very nice number, is it? Yeah? Right. What we should be able to do is find our angle from that. We should be able to find our angle. So the question would be, what is the angle if those are the two sides? And that is what we are going to be able to do. Right, that's where we're getting to, find the angle. But what we're going to do first is we're going to work at it from the other sense and say, if I know the angle, what will the sides be? That make sense? So we're going to come back to this question and we're going to say that ratio. So if I were to do two different lengths, that's the number I'm looking for. All right. So if I go back up to these ratios up here, these are the ones people looked at and they decided that they found that if these angles don't change, these don't change. And so they gave the numbers a name. So do you remember down there it was 2 point something? Well, they just gave it a name because that number changes depending on the angle. And they said opposite divided by hypotenuse, that relates to the angle, and we're going to call it sine of the angle. Okay? The adjacent over the hypotenuse is called cosine of the angle. And opposite over adjacent is called tangent of the angle. Okay? Can you see that all right? You want to write those down. Just to make it clear, normally what people do is they do a bit of a short cut and they write, instead of sine, they write SIN. But it's said sine. They just cut the E off. Cosine, we just write cos, but it's supposed to be cosine. And tangent, we just write tan. So you'll see them written like that on your calculator. Can you see them on your calculator?
Yeah.
Yes, you'll need a scientific one. Yeah. So this is where the scientific calculator comes from, because if you haven't got a scientific one, as Emily just found out, you don't have sine, cosine, tangent things. Now, to help maybe explain these things then, so what we're saying is, we'll come back to that question. If we were to take a triangle, excuse me, all right, if we take two sides, if I create an angle, so I draw an angle, and let's say that angle is 35 degrees. Okay? How many triangles, right-angled triangles, can I make with an angle of 35 degrees?
What was the question?
How many right-angled triangles can I make with an angle of 35 degrees? Well, I've got one there. Yeah? Can I not write another one like that? Yeah? So how many are there? An infinite number, yes. Because I can keep going smaller, right? Do you get that? So, as I move this side in, the triangle gets smaller, right? So this one, although it's an angle of 35, the hypotenuse, the what side? Opposite. Right, so I can't tell you the lengths of the triangles, but or you can tell me the ratio of the sides. So, without even knowing the lengths, because they're all different, could you tell me what the opposite, the ratio of the opposite and the hypotenuse should be? What would it be as a number? What would the opposite divided by the hypotenuse equal? You can use your calculator to determine. How would you do it? Any ideas? So I'm looking at the opposite sides and the hypotenuse, and I want to know what number would I get if I divided those two. How do we do it? We will get a decimal. Yeah. Exactly. This one is the sine of the angle, so I need to do the sine of 35. So in your calculator, press the sine button, S-I-N. Do that now. And then it will say sine of what? So you type in 35 for the 35 degrees and we get the answer.
0.57357643.
Long number. Now, that doesn't tell us on its own the lengths of any of the triangles. Or any of the triangle. But what it does tell me is the ratio of the sides. Does that make sense? So what's the ratio of the adjacent side to the hypotenuse? What do I use to find that ratio? Which one? Cosine. So this time, for this one, I need to do the cosine of 35. What do you get? 8191. So again, I don't know yet the sides of the triangle, but I do know what ratio they're supposed to be. And what's the final one? The opposite and the adjacent. How do I find that ratio? The tangent of 35 degrees. Okay? What do we get?
0.70020758.
And so on. Okay? All right. So that's how I find those ratios. Have you written those down?
Yep.
All of those triangles, all three that I've drawn, or any of the infinite triangles that I could draw with a right angle here, they've all got right angles. I could keep going bigger and bigger, or I could get smaller and smaller. But what is true is all of them will have these ratios. Okay?
Yes.
That's the clue. That's what we can use. All right. So, oh yeah, we have to go in 2 minutes, don't we?